CPU burst and IO burst. Process execution consists of a cycle of CPU execution and IO wait. This means process execution has two stages: CPU execution stage and IO wait stage. CPU execution means process is being run by the processor. IO wait stage means process has been blocked from execution because the process has issued some IO request, and until this IO request is completed, the process will remain blocked. Hence, CPU will not be executing the process when it is in IO wait stage. The process may have to wait for the completion of IO request for two obvious reasons. The first reason is because IO devices are slower as compared to the speed of the processor. Hence, after issuing an IO request, process must wait until this IO request has been serviced by the IO device. Secondly, because in time sharing system, there are multiple users and processes which might be requesting the service of this particular IO device. Hence, this IO device might be busy servicing the request of some other user or process. Consequently, our process must wait until the device is free and the request of our process will be serviced. Process alternates between these two stages, the CPU execution stage and IO wait stage. As this figure shows that a process keeps alternating between these two states, the CPU burst and the IO burst. CPU burst is the amount of time when process is being executed in the CPU. So CPU burst is the amount of time when CPU is executing the process instructions. So CPU burst represents the CPU execution stage. And IO burst, it is the amount of time when the CPU is waiting for the input or output operation to be completed. So it shows the IO wait stage. A process will keep running between these two states. In a single processor system, CPU sits idle in the IO burst stage or in IO burst cycle. So in a single processor system, why CPU will remain idle in the IO burst cycle? Because in IO burst cycle, CPU is waiting for the input or output operation to be completed. So until this operation is not completed, CPU will not be doing any work. It will remain idle. CPU runs only one process at a time. In a single processor system, CPU runs only one process at a time. And if there are more than one processes in the system, then other processes must wait until the previous process has completed its execution. So as soon as a process will complete its execution and CPU becomes free, then the other processes can be scheduled on the CPU. This figure shows the alternating sequence of CPU and IO bursts. Process execution begins with the CPU burst. So every process starts its execution with CPU burst cycle. CPU burst cycle is followed by the IO burst. That is, after this first CPU burst cycle, there will be an IO burst cycle in which process will be waiting for the completion of IO request that it has made. After the IO burst cycle, there will be another CPU burst cycle. And after this CPU burst, there will be another IO burst and so on. So process remains in the CPU IO cycle until it reaches the final CPU cycle. Final CPU burst cycle ends with the system request to terminate the program. So final CPU cycle contains an instruction that will request the system to terminate its execution. As we can see from this figure that CPU bus cycle may have instructions like load store, add store, and read from file. Now, read from file is a request to the system to perform a read operation from the secondary storage because a file may be stored on a secondary storage device. So after this, after the process has issued a read request, then it will enter the IO bus cycle. And in IO bus cycle, process will be waiting for the IO operation. Consequently, CPU will not be doing any work during this IO burst cycle. After this IO operation has been completed, the process will enter the next CPU burst cycle. And it may have instructions like store increment, index, and write to file. Now, write to file is again an IO instruction. That is, write to some file. And this file may be on some secondary storage device like hard disk. So again, the process has to wait until the system finishes writing this file. So process enters the IO burst cycle and it will be waiting for the completion of the IO operation. And what is the IO operation? Write to the file. And again, CPU will remain idle during this IO burst. After this IO operation has been completed, the process will enter the next CPU burst. And in this burst, there might be instructions like load store, add store, and again, read from file. So after having issued this instruction, again, the process will enter the IO wait cycle and it will wait for the completion of the IO operation. So this process will keep continuing. The process will keep progressing between these two stages, the CPU execution stage and IO wait stage. Again, there will be CPU execution stage and IO wait stage. Again, there will be a CPU execution stage and IO wait stage. And this process continues until there is a final CPU burst, a final CPU execution stage. And this final CPU execution stage, it will terminate the program by issuing a system request to terminate the program. Burst frequency. Duration of the CPU burst varies from system to system and process to process. So there is not a fixed time that how long a CPU execution stage will last. It may vary from one system to the other system. And similarly, it may vary from one process to the other process. An IO-bound program has typically many short CPU bursts. What is an IO-bound program? An IO-bound program is a program that performs frequent IO operations. And a program which performs IO operations frequently, this kind of program will have typically many short CPU bursts and long IO bursts. The examples of IO-bound programs include word processing, video games, and photo editing applications. These are the applications which are IO-bound because these applications perform frequent IO operations. They are based on user interaction. The second class of the program is CPU-bound programs. CPU-bound programs might have few long CPU bursts. A CPU-bound program is a program that performs, that spends most of its time performing calculations, are performing arithmetic and logical calculations. So CPU-bound program, they have few long CPU bursts and after which they terminate. Examples of CPU-bound program include scientific and engineering applications. Process scheduling decision is affected by the nature of the program. This means type of the program that either it is an IO-bound program or CPU-bound program. The type of the program, it has impact on the scheduling decision. So scheduler must pick a good mix of CPU-bound and IO-bound processes for efficient utilization of the system.